Hello everybody, and welcome to the Chapter 9 video for Introduction to Logic. So in this chapter, I'm going to explain term logic. But before I explain what term logic is, I'm going to try to give some justification for why we need it. So again, as I said in the end of the last video, everything we've been doing up until this point is known as propositional or sentential logic. I don't want to get too much into the history of this. It's a little bit strange that we learn propositional logic first because term logic's actually the oldest form of logic. Anyway, so to motivate this, so consider an argument. So, and again, examples are from the book, and there's a reason why they're from the book. I just put a lot of thought into designing simple examples. Anyway, so consider the argument. The first premise, all pies are pastries. Second premise, all pastries are delicious. Or conclusion, all pies are delicious. So if you just think about that for a second, I think you will agree that the conclusion does follow from the premises, right? It seems like if it's true that all pies are delicious, or if it's true that all pies are pastries, and it's true that all pastries are delicious, then it has to be true that all pies are delicious, right? They're all pastries, and all pastries are delicious. So common sense seems like the conclusion follows from the premises here. But let's plug in. So in each of these are statements, right? And they're not compound statements, each of the premises and the conclusion, right? So there are no logical operators inside of there. There aren't any, like ands or if and only ifs or nots in there, right? So we'd have to translate this argument like this. And I'm being a little silly here, but so P for the first premise, all pies are pastries. I for the second premise, all pastries are delicious. And then E for the conclusion, all pies are delicious. So, well, let's do a truth value analysis to see whether or not the premises imply the conclusion, right? And, well, just to clean that up, we can use fell swoop here. And from this point on, if I can use fell swoop, I'm going to. It doesn't really make that much of a difference, but this would be short anyway. Right, so drop this as the antecedent of a conditional, E. So because we have a false here, it's in the sort of logic that we've been doing. Our truth value analysis shows us this argument that the premises don't imply the conclusion, or in a more colloquial sense, the argument isn't valid. But it is. I mean, look at it. It has to be true. The conclusion here has to be true if the premises are true. So what we're going to do in term logic is we're going to look at special sorts of statements where we can look at the internal structure of the statement, right? To examine implication and validity. So what we'll be doing today is we'll be learning what term logic is, and we'll be learning how to test arguments like this one for implication. And so just so you don't freak out, as you might notice from the title, the way in which we'll be testing these arguments for implication is using Venn diagrams. And this is actually what Venn diagrams were invented for by, I forget the guy's name. His name was Venn. I can't remember his first name, in like the 1800s. So though we are learning a whole new kind of system of logic, the way we do it is we use techniques that y'all probably learned in 3rd grade. So it's not that scary. So term logic. So the two components of so we're going to learn different types of term logic sentences or term logic statements. Right. And the first component of a term logic sentence is a term. And so we represent terms with capital letters as opposed to lowercase letters. So terms are things like P or Q or R or S or, A or B, right? And a term is not a statement. So if we look up at our pi argument, so the terms are pies, pastries, and delicious. And pies isn't a statement. That's not the sort of thing that can be true or false. If you just, say the word pies, you haven't said anything that can be true or false. So the terms are components of statements. They're parts of the internal structure of a statement. And what they are is their adjectives or nouns. In English, their adjectives or nouns. That denote groups or categories. Or sets of things. So, if we if we put in P for pies, right, that stands in for things that are pies. What's another? D for delicious, things that are delicious. Right. In some textbooks, they make you rewrite. So instead of saying all pies are delicious, they'd make you rewrite that as all things that are pies are things that are delicious, or something like that, to get rid of the adjectives. But don't worry about that. I think you're all smart enough to catch what all pies are delicious means, right? And so term logic or terms are not true or false in the same way that sentences are, but terms can be true or false of an object. Right, so if we were to say that you were a pie, that would be false. It is false to say of you that you are a pie. It is true to say of all pies that they are pies, right? It would be true to say of you that you are a UCSC student, and there the UCSC student is a term that denotes a group of things. Right, it would be false to say of, The Rock, Dwayne Johnson, that he is a UCSC student, right? The term is false of him. So terms aren't true and false on their own. They're true or false of some object. Okay? So the first component of a term logic sentence are just terms, right? The second component of a term logic sentence are the types or forms. And so I think I go back and forth calling them types and forms in the textbook. Different logic books call them one or the other. And so there are only four. Well, there's sort of a fifth one. We'll get to it in a minute. There are four sentence forms for term logic sentences. So every term logic sentence that you're going to run into is going to be in one of these three forms. And they have names. And you should memorize these, not just because it's useful here, but because it'll help you when we get into quantificational logic, which is way more complicated than term logic. So the first, and they have letters that stand as a shorthand for that sentence type or form. So the first, it's known as a type or form A. And the traditional name for this is universal affirmative. And if we just pick two term letters randomly, and this is what Quine uses in the book, this is the form all F R G. So if we scroll up and look at our silly pi argument, right, all of these are type A sentences. All pies are delicious, right? So all FRG. That's the important thing to know. So the second type or form of a term logic sentence that you might run into is type E, universal negative. No FRG. Right. So the third type of term logic sentence that you will run into is a type I sentence, known as the particular affirmative. Oh, by the way, you don't need to memorize the like fancy names for them, but you do need to memorize the letter. The fancy names are just an acronym from like scholastic logic in the Middle Ages. If you're Catholic and went to Catholic school, they still refer to them probably by the long names. Anyway, so sorry. A particular affirmative sentence, a type I sentence, is some FRG. And one important note, and this is true here and also true for everything else in this course, the word some in logic means at least one. Right. So if you were to say the sentence, I don't know, some people are the president of the United States, in colloquial English, that might seem like you're saying it's more than one person, but in logic, some means at least one or more. And so that sentence would be true because there is at least one president of the United States right now, arguably. So the last type of sentence is a type O sentence, which is particular negative. And you might be able to guess what this one is. It's some F are not G. Right, and those are the only 4 types of sentence form or sentence type that there are in term logic, which is nice and convenient. And so what we're going to do now is we're going to look at how to draw the Venn diagrams that correspond to each of these sentence types. just as a little bit of a spoiler, the way in which we're going to use Venn diagrams to test is we draw in the premises and then we just look at them. So this is exceptionally easy. Fortunately, it's a nice little break to have in the middle of a class like this. Right, so type A, right? So all FRG. Okay, so we're gonna need two different circles at first, and I deeply apologize for how sloppy I'm going to be drawing these. I'm just not very good at it. So this is going to be F, and this is going to be G. And so how we would indicate the sentence all F are G is we shade. So when we shade here, this is a little weird, and you have to keep track of it. And there's a reason we have to do it this way. We can't switch it up. So let me just write this because it's important. Oh, whoa, way too big. Okay. So shading indicates emptiness. So if we wanted to say all F are G, how we would do that is we would shade in everywhere in the F circle that's not also in the G circle, right? I should use a different color for this. Oh well. You might want to look at the book just because the drawings will be substantially neater, right? So again, we look at this Venn diagram, and once we know that shading indicates emptiness, right, we see here that, well, we look at the F circle. There's nothing in the F circle that isn't in the G circle, and that shows us that all F are G. That's how we represent that sentence. Okay? So the next, we're just going to go through these in order. For type E sentence, whoa, way too big. That's probably good. So for type E sentences, sentences like no F are G. So remember, again, shading indicates emptiness. We draw our two circles. Right? Well, so if no F are G, that means that the area of the F circle that overlaps with the G circle is going to be empty. So if we wanted to represent that, just shade this in like so. Right? Again, I'm just going to write it again because this is the one. Basically, the only thing you can screw up on this is forgetting that shading indicates emptiness. Okay. So looking at the next sentence form for type I sentences, so and these are sentences like some FRG. So we draw F circle, G circle. And we're going to adopt a convention here where if we mark a little X, that's going to indicate non-emptiness. Right? So there will be, if we have an X in a segment of a Venn diagram, it'll mean that there's at least one thing that's in there. And so just we draw a little X there, right? So some FRG, right? What that means is well, look at the F circle and look at the G circle. Well, if some F are G, that means that there's going to be at least one thing that is both an F and a G. So in the circle that represents things that are both Fs and Gs, we put a little X like that, right? Then finally, type O sentences. And these are sentences like some F are not G. So draw our circle. Actually, it's way easier to draw these on an iPad than it is on a chalkboard. So some F are not G. Well, remember that the X indicates non-emptiness. Oops. And so to say that some F are not G, we would put a little x right here. What that tells us is that there's something that's an F that's not at the same time a G, right? There's some stuff about mutual contradictories in the book. If you really care, you can look at it. There's one other kind of, it's not really a sentence form traditionally. I don't know what to call it. I'm just going to call it like, this isn't a real name, but here. So there's one other way that we could shade in a Venn diagram that we do say sentences like this. So consider the sentence, there are no F. So I don't know, there are no unicorns, right? So if we have, our circles, if we wanted to say that there are no F, we would shade, oops, I need more thickness. We would shade the whole circle of F, right? This isn't a traditional canonical sentence type, but it is occasionally useful. I don't think Aristotle came up with it. Oh, by the way, term logic was invented by Aristotle. Aristotle is like, how do you explain Aristotle? Probably the most significant intellectual figure in the history of the world. He invented logic, the study of rhetoric, biology, physics, literary criticism. His works on literary criticism and philosophy, he was a famous philosopher as well. His works in a bunch of these fields are actually still read today. Not so much biology and physics. He was wrong about everything. Okay, so now that we know how to draw our diagrams, again, you just have to memorize these, the different ways of drawing them. But it's pretty straightforward. We're going to look at how to test arguments for implication using these. And so traditionally speaking, a term logic, So an argument in term logic is known as a syllogism. And so let's look at some syllogisms and look at how we do our validity test. So here's, again, an example from the book. Here's a syllogism. And again, I am not Catholic, and I didn't go to Catholic school, but I know some people who did, and an incredible amount of Catholic theology and doctrine and so forth is written in a syllogistic form. So there's a good chance that if you went to Catholic school, you've heard these a bunch, right? So let's consider this syllogism. So some pies are not savory to all pies are delicious. And then our conclusion is that some delicious things are not savory. Okay, and the way in which we're going to test this argument for validity is, again, we just draw the diagrams. So here, and there's one important thing to note here, is that you have to shade type A and E sentences before you put the X for type I and O sentences. If you don't do that, you will get the wrong answer sometimes. It's important to keep that in mind, but that's sort of the only sort of restriction to keep in mind. But do remember, I'm just going to say it again, you have to shade type A and E sentences before you mark the X for type I and O sentences. And then, so step 2, I guess that's step 1 is draw the diagrams. Step 2 is look at the diagrams. And if the conclusion is already marked or shaded, then the syllogism is valid. Oh, crap. For the first one, it's draw the diagrams for the premises. Sorry about that. You don't ever draw or shade in the conclusion. You just do the premises. Again, because I forgot to write that, I'm just going to say it again. You do not shade or mark the conclusion. You only do it for the premises. Okay. So I'm just going to grab this and bring it down here. Oops. 1 second. Okay. Okay. So let's look at this in some more detail. Okay. So let's just figure out the sentence types. It'll help us with our shading. So some P, so I'm also just going to replace these with letters. No reason we'd have to do that. There aren't schemata in term logic. We just use, wait, I forgot the letters. Yeah, some P are not S, okay. Then all P are G. And then some D are not S. And just to clean this up, okay, right. And this is just to help us see a little more clearly what the sentence form is. Again, no schemata. These aren't schemata. These are just English sentences, basically. So some P are not S. Let's scroll up. So that would be a type O sentence, right? All P are D. Well, that's a type A. Here, just to show you. Right? All F are G. All P are D, same type. And the conclusion, some D are not S, that's another type O. Okay, so we're going to need 3 different circles. So it doesn't really matter how you arrange these. It does get a little annoying to draw these cleanly, but here, wait. Oh, wait, I did it upside down from the way it is in the book. I'm going to redraw those. So, 1, 2, and then 3. Okay, there. I sort of did it. Okay, and then this is going to be, going to label these P, S, and D. Okay. So remember, we shade the premises, or we shade or mark the premises, and we shade before we mark. So here, right, this type O sentence is, we're going to need a mark for. We're not going to shade for it, but we're going to shade for this. So we have to shade the second premise first. Again, remember, we have to shade type A and E sentences before we put the X in for I and O sentences. So we do not just draw the premises in the exact order of the argument or the syllogism. Okay, all P are D. Well, so here's the P circle, right? And so if all P are D, that means that we're going to shade in everywhere in the P circle that is not also in the D circle. Like so-ish. Right? So all P are D. Cool. Right? And so then the only thing that we have to worry about here now is the first premise. This, and it's a type O sentence, so some P are not S. So we need to fill in or put in a mark or an X inside the P circle but outside of the S circle, and the only place we can do that is here, right? Okay, then how do we check whether or not it's valid? Well, let's look at our conclusion. Some D are not S. So is there anything in the D circle that's not inside the S circle? And yes, there is, right here. Right? See, that's in the P circle, but not inside of the S circle. So this is a valid syllogism. Right? Cool. I'm just going to go through and do another one. Again, this is remarkably straight. There's nothing tricky about this. Just remember to shade before you put in the X. Okay? So again, another syllogism, just another example from the book. So no pies are disgusting. Some pastries are pies. And then the conclusion is some pastries are not disgusting. Okay, so let's just replace our terms. So the terms in this sentence, just to get you in the habit of recognizing terms, are pies, disgusting, pastries. So those are, we'll need 3 different term letters for each of those. Maybe I shouldn't have used the same like pies and pastries because they both start with P. But anyway, so first let's replace pies. I'm going to put P in for pies. Then for pastries, I'm going to use an A. And then obviously D would be a good choice for disgusting. Okay, cool. So let's, here, let me just make sure that this ends up the same way as the book. Okay, right. So what we do is we draw our 3 circles. Those are too small. Again, these don't have to be perfect. Okay, and I'm gonna label them like this. Okay, so remember we have to shade before marking. Oh, I should write in the sentence types just to make this easier. So this is a type E. This is a type I. Right, and the conclusion is a type O. So remember, we shade or mark our premises. We have to shade type A and E sentences before we mark the other types. So always shade first, right? And we do not mark our conclusion, right? So again, here's what we're going to do. So this will actually go in order, right? Because this involves shading, and the second premise requires marking. And so what we're going to do is we're going to shade in, so no PRD. So we are going to shade in every part of the P circle that overlaps with the D circle. And if we do that like so. Okay, I should have switched over to like a more art-centric app for this chapter. Anyway, okay. Then our second premise, sum A R P, right? We have to mark. So we look at the A circle, and we want to mark the part where the A overlaps with the P. Oh, oops. Right? And then let's look at our conclusion. Sum A are not D. So our syllogism is valid if there is an X somewhere in the A circle that doesn't overlap with the D circle. And wouldn't you know it, there is, right here, right? That little x is not inside of the D circle. So this is, again, a valid syllogism, right? And so that's pretty much it for good old-fashioned term logic. That's the validity test. Those are the 4 sentence types. Maybe I should rearrange the book to teach this first just because it's easier. And it's great when we have arguments or syllogisms that are in, this simple form. 2 premises, 1 conclusion. It goes really swell. And it would be great if we didn't need anything else. But what we're going to be doing for the rest of the course is, however, so there are arguments and relations that obtain between different sentences that mix and match kind of term logic and sentence logic. So you might wonder why we can't do something like, I don't know, if all pies are delicious. Then everyone eats a pie. space. Some pies are not delicious. Conclusion. Not everyone eats a pie. Right, so this here, there's an if-then there. But we're mixing and matching propositional logic and term logic. So just as a little spoiler of what we're going to do going forward is starting next week, we are going to learn techniques to deal with arguments and sentences like this that mix and match term logic and propositional logic. And that's when the class starts to get pretty difficult, and that's why the pace kind of slows down in the second half of the course. So that's where we're going with this. But hopefully these exercises will not be very difficult at all. It's Venn diagrams. I think I learned my first Venn diagram in kindergarten. So I think you guys can manage, memorize the sentence forms, right? Remember to always shade before you mark. And try the exercises. I don't think you'll have very much difficulty with them at all. One thing I wanted to point out as a standing extra credit assignment. So in the section of the textbook, it's on page, I think 73. Let me double check. Yeah, 73. There's this really long, how many lines is it? 10 premise syllogism. It's by Lewis Carroll. It starts, the only animals in this house are cats. And then there's, more. So I will give, when I took this class, my professor offered a ton of extra credit to anybody who could actually prove that argument to be valid using syllogisms. And it's 10 premises. So what you have to do is you have to, I'll post another video of this where I explain how you might actually try to do it, but you have to do a bunch of intermediary syllogisms. So you can't obviously overlap 10 circles with each other. It doesn't, it's pretty much impossible geometrically to get them all to overlap, right? So you have to, I'll post a video where I explain it, but going forward, if anybody can prove that argument, that the premises of that argument imply the conclusion using any of the techniques that we have learned or will learn, I'll give you a ton of extra credit points. Anyway, enough with that. So that's all there is to know about term logic and Venn diagrams. It's not very scary. Good luck with the exercises, and I will talk to y'all next week.